Hello friends, welcome to BISP Solutions. Myself Ashwin and I work as a technical consultant at BISP Solutions. And BISP Solutions is a tech company that provides technological solutions across the world. Okay, so our today's webinar is all based on our PyTorch. Today is the first day of our webinar, so we are going to just have an introduction of PyTorch, right? So what is exactly the PyTorch, right? So it's a tool, or we can say it's a framework in which we can utilize, we can use it for the concept of machine learning and the concept of data science, everything, right? Now today what happens, every business they use these machine learning concepts and regression concepts for making better decisions in their businesses. For example, previously what happens when there were no any tool of predictions, right, or predictions, or we can say the machine learning concepts, so they were taking decisions, and then they face many times they face heavy loss due to the wrong decision making, right? So now what happens, we will now the prediction methodologies are used to predict whatever the future. For example, if I say that the company is having the sales record for last 4 years, now how would I take decision, and what will be, how would I know that in future also, within the next 2 years also, we will see what trend we will see. So these things can be done with the help of some regression techniques. Now, but the thing is that before going to regression, we have to see the basic concept of exactly what the PyTorch is. See, PyTorch, first of all, I will show you, just a second, give me a second. PyTorch, linear regression, okay, yeah. So PyTorch is nothing, it's just a tool, it's just a library. You can view it as a library that in which we use the tensors. Now, tensors means exactly what? See, whenever it is related to machine learning, see, there are two parts. One is the machine learning concepts and another is regression concepts, right? So in our next webinar I will show you what is the regression, how we can predict. But today, if since this is our first webinar, so we are going to see what is exactly the PyTorch, what is the tensors, because the very first thing that you should know about the tensors is that how it works, right? So that's why I am starting this, exactly what the tensor is and how it works, right? So let's have a quick start, and then I will also show you practically also that how these tensors are created. Now first of all, let me explain you about the tensor. See, tensor is nothing, it's a array. For example, suppose if I put a photo in front of you and if I ask you that how many vehicles are shown in that image, so in that case what you will do, we can recognize that this is a photo and this is the object, that whatever you are seeing. If I ask you that these are the 4 years sales data, and this year also how would be the sale, so based on the observation of that previous sales data, and based on, for example, this year the temperature in the atmosphere in the summer season, the temperature is very high, so definitely it will be better for the sales of our cold drink plant, right? So but how this tensors, how this machine learning will do? So machine learning, when we talk about the machine learning, so machine learning, what it does, the tensor, it converts the image or the data into the tensor format, and then when the tensor what we say, the calculation is done on the tensors, and then that tensors, based on that, the result is evaluated. So this is how the tensors works, right? Let me explain you here. Suppose if there is only one element, then it is called as scalar. Now if you see here, only one row is there, so that is called the row vector. So first we will see these concepts, and then we will come to know how to manipulate on tensors. If there is one column here, so it is called column vector, and then if you see here the matrix, so it's a column by row, right? So column 3 and row 2, 3 by 2 matrix. Similarly, multiple columns and multiple rows, so that is called tensor, and it's a 3D, right? So the x, y and z, you can see here 3 axes, so that is called the tensors. Now this matrix, I think everyone is aware of this matrix because we have already learned in our mathematics before graduation. We have already learned this matrix in mathematics, right? So these are called the tensors. Now tensors, there are different usage of tensors. For example, if we show the image to the PyTorch, if you put that image to the PyTorch program, so what it does, it converts the complete image into the tensor, and then it works on that tensor, because whatever the image you send, it converts that image into the tensor into the form of numbers. It divides everything into the numbers. For example, whatever the color is there, whatever the size is there, whatever the shape is there, so everything is divided into tensor, that is the matrix, and then manipulation is done. Now if you see here, there are different types of tensor. Just let me show you this. Yes, now look at this. This is an example of how the tensor works, right? Now see here, introduction to PyTorch tensor. Now in PyTorch we use tensors to encode the inputs and outputs of a model as well as model's parameters. Now see, if I show you this, now suppose this is the image, right? Before data gets used with an algorithm, it needs turned into the numbers, okay, right? So this is our image, that is the Maggi noodles, or you can take any image, right? Or you can take the input as a text, or you can take the input as a voice. Everything will be converted into the matrices form, right? So these are the tensors, right? Now matrix, this 11678, it is automatically created, we don't need to do anything. Then choose the appropriate neural networks for your problem. So it is also done by PyTorch only. Now ultimately, after having a look and after comparing that input with the whatever the data we have into the database, it take the conclusion exactly what type of image that you have served. Same thing is here. Suppose let me give you a real-time example. Suppose nowadays in metro cities, if you see, if a person is not wearing any helmet, so what it does, immediately the camera detects that person without helmet, and then automatically a challan is generated or the receipt is generated and send it to the particular person. So what, at the same time, what camera does, first of all, it will detect the image without helmet, whichever person is without helmet. So, and after that it detects if any person found, so in that case it detects the number also of that vehicle, and then immediately it takes the decision. So this is how the use of tensors and matrices we can make use of in our daily life, right? So these are some small projects that we used to create in tensors. Now the another thing is that regression, right? So second, now see here, if I show you this matrix multiplication, now once the things are converted into the matrix, right, or we can say the image is converted into the matrix, everything, so multiplication, addition, subtraction, everything is done mathematically, and I will show you practically that how this is done. When we will work on it as a developer, or when we will work on a project, so we don't need to follow these all rules, but what happens in the back end, that we need to know, right? So I will show you the practical also. After that, here is the restructuring of tensors. There are different commands which are used for restructuring the tensors. Okay, now here is now let me show you the practical part of the tensors, exactly how it works, and then later on we will see how the regression works, right? So, we will just have a look up on regression also, exactly how this regression works. But first of all, let's have a look on the tensors, right? So let me show you this, just a second. wait a second, right? PyTorch tensors, right? PyTorch and tensors. So actually I have already created this, but I will create a blank instance of PyTorch tensors and then I will show you, right? So for easy understanding, it will be more easy for you. So PyTorch tensors examples. Let's create Python interactive Python file, right? So let me start from here. Okay, PyTorch tensors practical example. It will take a little time. Okay, let me rename this PyTorch tensor practical example. Let's take example, right? And then I will rename it. Okay, now first of all let me take, I have already created this first PyTorch and tensor fundamentals, right? So we are going to learn this. So see, while practicing on Jupyter, you have to install first the Jupyter notebook. Exactly what is Jupyter? If you go and search on Google Jupyter notebook, install Jupyter notebook, that's it. So immediately it will be installed and then you have to click and run this. Now you can see here, this is a notebook. It is just like an editor. For example, if we use Notepad++ for writing the code for any programming language like PHP, Laravel, Python. So same thing is here. This is an editor in which we write the data science concept and the PyTorch concept and everything regression related to regression. Each and every code we write down, right? So, and this is a code markdown and raw. So what is this? First of all, we have to make it as if I go, that's it, right? PyTorch and tensor fundamentals. This is the heading. And now after that, first of all, we will see here the scalars part, right? Scalars, and then if you put in code and then if you put the enter, right? So it will throw an error, right? So because that's not a code, so you have to make it as either raw or the markdown, right? Now let's start with this. First of all, what we see, import torch and torch vision. Now see here, these are two libraries. Now look at this. Here it is written code and import torch and torch vision. It is just like other programming languages. We have to first import the library torch and torch vision. Now inside the torch and torch vision, there are so many functionalities, so many properties that we are going to use, right? So in this way, what we are going to do here, let's start right now. Look at this. Now this is ready to work. Okay, and now what I will do here, just let me close this unnecessary. Okay, yeah. Now see here, scalar equal to torch tensor 5. Now see here, first of all, we are creating torch tensor 5. That means a scalar, it's a scalar, and tensor we have given torch.tensor and value is 5. So just now I have explained you this. Look at this scalar, right? Only one value. So only one value is given here. Okay. Now let me show you this scalar dot ndim. So ndim means exactly what? So if I put here dimension, here it is 0, right? Because neither it's a row nor it's a column. So it is just showing ndim. Now how many items are there in the scalar, right? So if you these are the commands that I recommend you to practice this, right? So whatever the items, only one item is there, that is the 5, right? So these are the commands and the properties, right? Now what are the vectors? Okay, so let me start with the vector. Just put here vector, okay, and then make it as markdown and then just enter, right? Now we are going to see what are vectors. So see here, vector, row vector and the column vector. So I will explain you the how to create these row vector and the column vector. So vector, this is a just a second. Look at this here. Now vector equal to torch dot tensor 5,9. Now it's a row vector, right? Tensor dot torch dot tensor 5,9. So this is how we create the row vector. Similarly, if I go here again and then n dimensional, if I go here, write this, dimension is only 1, there is no another dimension, right? Okay, now let's come here again. Now the another next part is, if you see here the matrix, right? Now see here matrix. So again we have to make it as a heading. So I am adding these headers because for the easy understanding for you. Okay, so now look at this matrix. Now matrix equal to torch tensor. Let me put this here. Now see the creation of this matrices. Matrix is so easy. Look at this matrix 498 1635, right? So similarly these are started with the box bracket, right, square brackets, and here you can see, and the ending square bracket is this, right? So in this way the matrices are created, right? After that, if I show you dim, again the dimension. Now see what these are, some very important commands while working on any small project. You will need this. Now see here 2 dimension, right? Since it's a, there are two rows you have given, right? So dimension is 2. Okay, then if I again matrix dot shape, we will go from basic to higher level, right? So that's why today I am only showing you the tensors and how we create the tensors and how to multiply, manipulate the tensors. Okay, so what is the shape? 2 by 3. Look at this, 2 is the row and 3 is the column. Look at this, right? So in this way torch dot size, and torch dot size, that is matrix dot shape equal to size is 2 by 3. It has shown the shape. Okay, now after that torch size 2,3, just a second. Okay, no, sorry, that's not the command. Okay, now see here matrix, if I click this, right? Now let me explain you this. Matrix equal to torch dot tensors, and we have given here first row, second row, the third row and the fourth row, right? 1 2 3 4 5 6 7 9 10 11 12, right? Fourth row. Now in this we will see first of all print matrix. Okay, this is the print matrix, right? Then matrix dot dimension, matrix dot dim, right? So dimension is showing 2 and size is 4 by 3. 4 is the row and 3 is the column, right? Dim, let me do it again. Dimension is 2, that's fine. Okay, I will check it out, and we will again practice this in one upcoming sessions also. So now if I show you, let's go to the tensor here, tensor variable, right? So we will create some other variables also, like control variable torch dot tensors, right? So now here let's come here. Now look at this, everything depending on this, right? If you see here the square bracket, it first square bracket ends, start here and ends here, right? So this is the one matrix, and inside this if you see here another bracket, another matrix start from here and it ends from here, right? And overall this is the ultimate square bracket. So in this way inside this 2 matrices are created, or we can say the 2 tensors are created. Okay, see, and dim. If I go 3, look at this, here the dimension is 3, right? So that's why it creates dimension. Now if I show you the shape also, let me show you the shape. If I show you shape 2 3 by 3, now what does that mean? Size means 2 matrix and the size is 3 by 3. Look at this, 3 by 3, 3 row 3 column, 3 row 3 column, and these are 2 matrix, right? So that is why. So the main thing is that you should understand exactly what the code is being written and how it is, what thing is showing what. For example, 2 means the number 2, 3 by 3 means here is 3 row 3 column, 3 row 3 column. Okay, so now again we will go to our another command, that is torch size. Okay, now what we are doing, okay, now torch dot rand random. Okay, so let's start here. If I let me put this as hash, and here is markdown, and then now look at this, generating random tensors. We use torch.rand to generate tensors of any size, right? Some examples are provided below. The random number is pulled from the uniform distribution and the interval, right? So let me run the command here. I have already written here. Look at this. Now see, tensor underscore variable, we have taken a variable, and torch dot rand, it comes from random, right? 3 by 5. So if I enter this, now see here you can see 50, 74, right, and 39, 47, and if I again run this, look at this, 84, 46. Every time the number changes. Why? Because we have commanded the PyTorch to create a tensor where the row are 3, look at this, 1 2 3, 3 rows, 5 columns. So 1 2 3 4 and 5 in this way. And since we have used this keyword RAND, so every time the number changes. Clear? At the very first time if you practice this, it will be a little bit difficult, but if you keep on practicing, the things will get clear to you. Suppose similarly I am giving you one more example. Now see here, 5 means 5 row, 1 2 3 4 and 5, and then column are 3, right? So every time, again this is RAND, randomized. So again if I put, look at this, the number, all numbers are changed. Similarly, torch rand, just a second, we will make some. Okay, now so far what we have done, 5 comma 3, right? Here one more thing is added, 2. So what does that 2 means? Look at this. Now tensor underscore variable equal to torch dot rand random and 2 comma 3 comma 5. So 3 comma 5 means 3 1 2 3 and 1 2 3 4 5 columns. Again 3 row 3 and 1 2 3 4 5. So 3 comma 5, and you have to create 2 matrix inside this tensor. So this 2 shows this. This is 1, this is 2, because they are separated with square bracket, separate square bracket, right? So this is how this 2 means 2 comma, if in future if you see this like torch dot rand and 2 comma 3 comma 5, so immediately you will come to know about this, right? After that, here if I go torch, let's take one more example for this. If I look at this, 5 means 5 times matrix, and 2 comma 3 means 2 row and 3 columns, right? So now it is clear to you. Okay, then okay, 3 comma 5 comma 2, torch variable torch dot rand. Okay, now tensor with zeros and ones. Now see, many times what happens, we need to create tensors of one variable, one value. For example, the tensor only 0 contains only 0. In that case what will happen? So let's practice that also. If you go here, okay, now if I put this, now look at this, tensor underscore variable equal to torch dot zeros 3,4. Now what does that mean? Torch dot zeros. So zeros is a property in which it will create a matrix of 3 by 4, 3 row, 4 value, 4 column, 1 2 3, 1 2 3 and 4 columns. But here you have written zeros. So zeros means 0. That's it. Similarly, we have one more command, that is once. Okay, so now once. So once means exactly what? So tensor variable torch dot once, then 3,4. Again same thing, 1 1 1 1. There is nothing like 0.1 or 0.01, nothing, only 1, right? Here you can see here 1 1 1 1. 3 by 4 means 3 row and 4 columns. Okay, after that, now we can see here tensor with range. We have to show the tensors with range. Here go to markdown and then see here. Now what are these tensors with range? When we are putting some range here, for example, let me show you. Now see here, tensor underscore variable torch dot a range. Now again this is a property, right? How we have to give the range, a range, right? Now start 0 and 10 step 1. Now start 0 and 10, that means start with 0 and 2 and with 10, and step equal to 1 means 0. What is one step? 1. Again take one step 2, again take one step 3. Now in this way. Now suppose if I take here step 2, right? Now see carefully what happens here. Look at this, 0 step 2, that means 0 to 1, 1 to 2. Again step 2, 2 to 3, 3 to 4. Again step 2, 4 to 5, 5 to 6, and 6 to 7, 6 to 8, right? And ends with 10, right? So in this way, after practicing you will come to know exactly how it comes, right? So now this is how the a range. Now if I put here, suppose, let me show you one more example, right? Tensor variable equal to torch dot a range, and then start with 0, end with 100, and step equal to 10. Now step equal to 10 means what? So 0 to 10, then 10 to 20, 20 to 30, 30 to 40, 40 to 50, 60, 70, 80, 90. And it starts with 0, but it started with, it ends with 100 means below 100. 100 will not be counted. For example, if I put here 20, so what will happen? 0 to 20, 20 to 40, 40 to 60, 60 to 80, right? So in this way, these tensors, these properties works, right? Now let me show you one more example, that is if we take here this tensor variable and then look at this, start with 1, that means 1 is included, and this 50 will not be included, right? 1 is included, that 50. Similarly here, if you see here 90 to 100, why it is not given, right? Because steps are 10 only. Look at this, only 10 steps, 1 2 3 4 5 6 7 8 9 and 10, right? Similarly here also you see here steps 5, take by steps 5, but this 50 will not be included. Why this 50 will not be included? Because 46 plus 5, that is 51. So we can't write this because ends at the time when the 50 comes, automatically this loop will end. Okay, so this is how it works. Now let's move ahead, and what next is, let me show you this also. If I click here, just a second, mark down, and then now see here, the tensor data type, the default data type of the tensor is float 32. Default type, it is taking float 32. Now if you see here, look at this, we have taken 1, but it has written here 1 point something, right? You can see here point also. By default it has taken. We have not given anything like int or float, but by default it has taken, right? So that's why it is written here, such as float 64, float 16, right? Now I will show you one more example of tensor here. Now tensor underscore variable equal to torch.tensor 3, 3.0, 4.0, 5.0, 6.0, right? And data type we have not given. So now if you see here, float, look at this, float 32. D type is float 32. We have not given here anything, none. We have given here none, but still it has taken float 32. That means that is why it is written here by default. By default data type is PyTorch is float 32. After that, if let's go a little downside here, type, and if I specifically write here, look at this, here I have specifically write here float 16, right? Float 16, and tensor variable, same tensor variable is taken 3.4, 4.0, right? 3.0, 4.0, 5.0, 6.0. So now it has taken variable torch.float 16. Clear? After that, this was all about the float. Just a second, where we were doing. Here it is. Okay, float 16. Okay, we were doing this, and now tensor. Similarly, if I show you this, right, and if I make it here like look at this, we have already given the integer value. Now when integer value is given, it automatically takes int 64. Otherwise, if you put here like point 3.0, 4.0, it automatically takes the float value. So that's the automatic system it has. Now suppose if we specifically put here like int 8, right? If I put this and tensor variable int 8, so by default it is int 8. Okay. Now tensor operations with PyTorch. Yes, this is most important, so pay attention on this. Tensor operations with PyTorch. Exactly what it is. So tensor 1, tensor 2. Now we come to know that exactly the tensor, what is this tensor, and now let's perform this operation here, mathematical operation. If I put here, now see here, tensor 1 equal to torch.tensor 1, 2, 3, and tensor 2 equal to torch.tensor 2, 3, 4. And these are the operations that we are going to perform on this, right? So print tensor 1 multiplied by 100, tensor 1 plus tensor 2, tensor 2 minus 100, minus, plus, multiplication, division, right? Everything we are going to perform on this tensor, right? So just hit enter. Now see, I will show you one by one all, everything I am going to show you. Now look at this, print tensor 1 plus 100. Now print tensor 1 plus 100 means exactly what? 100 will be added to all these values, 101, 102, 103. So that is what this value comes from. Okay, so this value comes from that operation. Similarly, if you see here, print tensor 1 plus tensor 2. Now tensor 1 plus tensor 2 means this 1, 2, 3 plus 2, 3, 4. So it will be directly added. Look at this 3. This 3 means 2 plus 1, 3, 3 plus 2, that is 5, and 4 plus 3, that is 7. Clear? After that, if I put this minus, again the same thing, minus 100 minus 1, that is minus 98. Okay, tensor 2 minus 100. Here it is written tensor 2. So this is the 2, 3, 4, and 100 minus 2, that is minus 98. 100 minus 3, 97, and 100 minus 4, 94, 96. Negative, right? After that, tensor 2 minus tensor 1. Now how it is done? Tensor 2 minus tensor 1. So 2 minus 1, that is 1, 3 minus 2, that is 1, 4 minus 3, that is 1. Look at this. Tensor 2 is here, tensor 1 is here. 2 minus 1, 3 minus 2, 4 minus 3. So in this way, subtraction is done. After that, multiplication. This is most important. So how it is done, right? So multiplication is most important. So now tensor 1 multiplied by tensor 2. Okay, so this is done like this way. Tensor 1 multiplied by tensor 2. So 1 multiplied by 2, that is 2, 3 multiplied by 2, that is 6, tensor 1, that is 2, 3, 2, 6, 12, right? So 2, 6, and okay, multiplication, that is since there is only one row, right? So there is only one row, so that is directly multiplied with each other. 2 multiplied by 1, 3 multiplied by 2, 4 multiplied by 3, that is 12. Very simple. Now suppose if there are more than one rows, in that case the calculation will be different, right? So right now this is similarly simple, very simply multiplied. 2 multiplied by 1, 3 multiplied by 2, 3 multiplied by 4, that is 12. 2, 6, and 12. Similarly, dividation. If we divide this tensor 1 by, so 1 by 2, that is 0.5, 2 by 3, that is 0.36, right? So 6, 6, 6, 7, and 3 divided by 4, that means 4 7s are 28, right? So this is how direct division, direct multiplication, because since there is, we have taken only one row, right? That's why. Now let's come here also, just a second. Matrix multiplication. Now this is most important, matrix multiplication. Now we are going to learn what are matrix multiplication. So these things are necessary for every person to learn. So that's why today I am showing you all these important operations, how it works, because when we will go ahead, we will not repeat the same thing. So that is why I recommend you and suggest you to watch this video once more time, right? Because when we see anything in first attempt, it becomes a little difficult also, right? So now see here, if I, okay, and Control C and then Control V. Now this is most challenging. How it is done? And let me A multiplied by B. Okay, so first of all let me show you this 1 comma 2 comma 3 and 4 comma 5 comma 6. Similarly, after giving some space, 1 comma 2, then here 3 comma 4, and then here 5 comma 6. Now see how it is done. First of all, focus on this 1 2 3 and 1 3 5, right? 1 2 3 and 1 3 5. Focus on this only, right? 1 2 3 and 1 3 5. This 1, this 3 and 5. So 1 multiplied by 1, 2 multiplied by 3 and 3 multiplied by 5. For example, if I show you like this, like just an example, if I have 1 2 3, 1 comma 2 comma 3 and 4 5 6, 4 comma 5 comma 6. Okay, this is the 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, 1 2 3 4 5 6, right? Now what I will do here, this and this. So what happened? I will multiply this 1 with this 1, 2 with this 3 and 3 with this 5. So ultimately the result will be 1 multiplied by 1, that is 1, then 2 multiplied by 3, that is 6, then 3 multiplied by 5 means 15. It becomes 15 plus 5, that is 20, 21, 22, total 22, right? 15 plus 7, that is 22. So look at this, 22. Similarly, again same thing. Now focus on this here. This 1 2 3 will be multiplied by these 2 4 6. So what will happen again? 1 multiplied by 2, 2 multiplied by 4 and 3 multiplied by 6. So what happens here? 1 multiplied by 1, that is 1, plus 2 multiplied by 4, that means 8, plus 3 multiplied by 6 means 18. So 18 plus 1, 19, plus 1, 20, plus 7, 27. Total 27. Okay. 1 plus 2. Okay, here it is 2 because 1 is multiplied by 2. Okay, so 2. So 18, 19, 20 plus 1, that is 28. Okay, so here it becomes 28. So in this way this 28 comes here. Similarly 4 5 6. So again the same process. 4 5 6, this 4 5 6, if I show you, again 4 5 6 will be multiplied with 1 3 5. So 4 multiplied by 1, that is 4, 3 multiplied by 15, that is 15. So let's put here 4 plus 15 plus 5 6 are 30. So 30. So 30 plus 4, 34, 34 plus 10, 44, 44 plus 5, that is 49. Yes, here it is 49. Clear? Similarly, again same thing, 4 5 6 multiplied by, so what we will do, again 4 multiplied by 2, that is 8, 5 multiplied by 4, that is 20, and then 6 multiplied by 6, that is 36, right? So 8 plus 20, 28, 28 plus 36, 28 plus 30, 38, 48, 58, and 59, 60, 61, 62, 64, that is 64. Look at this, 64. So this is how, and this is not a different thing. Everyone might have seen in before graduation in mathematics, there is a trigonometry. In that matrix multiplication, everything is shown here, right? Okay, so now let's move further. Transpose tensor. Okay, transpose tensor, and this operation is done with the help of matrix multiplication. So matrix MAT multiplication MUL. Okay, similarly, if I show this, like let's do this, mark down, enter. Okay, so transpose tensor. Sometimes we might need to transpose the tensors. For instance, turn 2 by 3 matrix into 3 by 2. In that case, you can use tensors or T, where T means transpose. Okay, tensor dot T. Look at this. This is complete command in itself. Tensor dot T. So now let's see this. Look at this. It's very simple. But the thing is that you need to watch it again, twice, thrice. If you don't understand, you can practice it again. See, now suppose if I put here A also, right? And now I will enter this. Print A. Now look at this. What happened here? A equal to torch dot tensor 1 2 3 4 5 6. So similarly, it has very simple way it has written like this, because we have already given 2 rows. Now transpose means the row becomes the column and the column becomes the row, right? Or don't look at that, column becomes the row, just row becomes the column. That means this 1 2 3 we just rotate it 90-degree clockwise, it becomes here like this 1 2 3. Similarly 4 5 6, consider it as a straight line and then just rotate it 90-degree. So in that case it becomes 4 5 6. So row becomes column, right? That's it. So now here you will see transpose. So transposing, this is a very Excel sheet concept, right? Now tensor aggregation. Okay, and then I will put here the hashtag. Okay, now look at this. Tensor 1 equal to torch dot rand means random. 2 comma 7, that means 2 rows, create a 2 rows and 7 columns, and since it's random, so by default the float value is taken every time this number changes, right? If I show you again and again, the numbers keeps on changing. Now torch dot minimum tensor, that means whatever the minimum value is. Now see here, whatever the minimum value. So now it will first check this tensor and then it will check for minimum value. So minimum value is there is nothing like 0.1. Here comes 0.20, and below this there is no value. Everyone is having here 8, 4, 5. First of all, it checked to 0.2. So 0.2, this is also 0.2, but 0.28, and here 0.20. Okay, so that is why it is considered as very small minimum number. Okay, then if I put here max, right? Suppose right now we will see what is max, right? I will not hit the enter button here, and let's see. 3 5 6 9 7 9 7. Here is the 9 8, then another big number 9 8. I think this is the biggest number, right? Yes. So this 9872 is the answer, I think. Look at this, 9872, right? So 9872 is the correct answer. So maximum number. Similarly, if you see torch dot mean, mean value will be extracted. And then after that, if I go here, torch dot sum, right? Suppose if torch dot sum means the addition of all. So it has shown you the addition of all. We also have tensor dot argmin. Okay, there are some more functions here, so let me show you that also. And then first we will go here, hash, and then I will show you the markdown, right? Today we are doing this practical because I want to make you familiar with this, all these tensors, exactly what it is, right? And if you watch this video again twice, thrice, things will become clearer, right? Because we have to do much more in this. So first, this is the very first session today, so I recommend you to watch this and practice it by your own. That's why I am putting all these narrations and all these headers, right? Okay, now here tensor1 dot argmin. So tensor1 means already created this tensor1, right? It will take that only. So argument of argmin, average mean, right? So argmin means whichever is the 9 okay, mean value, okay, minimum value. Then after that, if I argmix max to find the position of the minimum, okay, yeah, this is here it is written. That's why that is the benefit of writing the headers. Position of minimum, look at this. So position of minimum is what? See here, minimum position 0.2039. So 2039 is where it is, 2039, right? So 0 1 2 3 4 5 6 7 8 and 9. So 2039 means minimum, whatever the minimum value is there, what is the position of that particular. So it has shown here 9. And max, so max means 9872. So 9872, so it will be 10, right? So let's do it. Max, argmax, right? So it will be 10, right? Just one step ahead. Okay, so in this way. After that, restructuring of tensors. So what we are doing here, restructuring of tensors. So again I will put here and then I will see the hashtags, okay, and then markdown. Now see here, restructuring means basically we are reshaping, right? Reshaping. So let's take an example here. Look at this. A equal to torch dot arrange 0 to 20. Again step 2, that means 0. Step 2 means 2. Again take 2 steps, that is 4, 0, 2, 4, 6, 8, 10, right? Step 2, and right, and ends with 20. So 20 will not be counted. Okay. Now torch dot size. Torch dot size is 1 2 3 4 5 6 7 8 9 and 10. Total 10 element. Clear? Now if I show you a reshape, look at this. Now reshape, convert it into 2, 5. Now see, we are having one complete line here, right? And we are now reshaping that one dimensional array, 1D array to 2D. So what happens here? We have given the command that 2, 5, that means 2 rows and 5 columns. Just to reshape. Suppose 1 2 3, total size is 10. Suppose if I put here 2 row, right, and 5 column. Suppose if I make it as 6, it will throw an error. Look at this. Why? We have not distributed the shape properly, right? So that is why it is throwing an error. Okay. Similarly, a dot reshape, comma 2, comma 5, that is fine. Viewing, okay, viewing. So the viewing of tensor, let's have a look here also. And then instead of writing code, take a markdown. Okay, so now viewing. So tensor 1 torch. Now look at this. Tensor 1 torch, that is tensor 1. Okay, after that tensor 2. Look at this. Tensor 2 equal to tensor 1 dot view. That means convert the view of tensor 1 into 2 comma 5, that is 2 row and 5 columns, and put it into tensor 2. Suppose if I put here tensor 1, there is no impact on tensor 1 because we have taken a variable here tensor 2, and that tensor 1's view is converted into 2 by 5. Okay, and now changing an element here. If I show you this, the final command, look at this. Tensor 1 tensor 1 that is 12. So look at this. Tensor 1 changing the element. So tensor 1 12, that means go check this tensor 1 and in first position 0 and this is 1, put 11, put 12, right? Similarly print tensor 1 and tensor 2, same thing. Tensor 2 will also show the change. Look at this, tensor 2, right? Suppose if I make it here like 2, look at this. Previously this was changed, now this was changed. That means once the change is done, change is permanent, right? So now in this way we have today learned the tensors, and I also suggest and recommend you to watch this video one more time, so that will create an interest in you that okay, this is how it works. Because if you just keep on watching the video, that will not help you, right? So my suggestion is to you is to just go through this video once more and then practice this tensor. Next part we will see regressions, right? What is linear regression? If I show you this, what is linear regression, what is polynomial regression? Regression techniques are used for prediction purposes, right? So that is how we use the regression for prediction purposes. But today first you practice this, and in our next session also this PyTorch, tensors and linear regression algorithm, everything will be used twice, thrice. So if you could not understand any point, not to worry about that, we will cover it in our upcoming sessions one more time, right? And if you have any doubt, if you have any error coming, then take the snapshot and put it into the comment box. I will help you in that, right? And those who are new to this channel, please subscribe my channel. Okay, so today we will stop here, and we will in our next webinar we will see what is the regression techniques, what is regression, right? Okay guys, thank you for watching attending the webinar. Okay, see you in our next webinar. Okay.